Hello everyone, today we're going to look at applications of right triangles. So these are going to be word problems, and you're going to have to find the right triangle within the problem and solve for typically just one piece of missing information. So it's nice in the fact that you don't have to find all three pieces, you only have to find one, but it is a word problem, which means you do have to draw it out and find the triangle. It is really, really, really important that you actually draw the picture. You gotta make sure that what you're labeling is correct. Okay, the biggest mistakes that I see is people don't draw it, and then they'll label something as the hypotenuse when it's really the vertical leg, or they'll solve for the wrong angle or something like that. So make sure you do draw it out. So for our first example, we have that Horseshoe Falls, which is on the Canadian side of Niagara Falls, can be seen from a small boat 2,500 feet downstream. The angle of elevation from the observer to the top of Horseshoe Falls is 4 degrees. How high are the falls? So before we start drawing the picture and trying to find out the answer, I want to talk a little bit about what it means to be an angle of elevation. So we have angles of elevation and we have angles of depreciation or angles of depression. So these angles always start at someone's eye level. So if I think of a person, they are looking horizontally, and an angle of elevation, they're moving their head up. So this is an angle of elevation. An angle of depression is, again, they're starting at their horizontal eyesight and they're depressing their head down. So this is an angle of depression. So an angle of elevation and an angle of depression, they always start at a horizontal. So it's very, very important. If I'm looking at a triangle, then my angle of elevation is this guy here. My angle of depreciation is this angle here. So I'm never going to have an angle that's up against the vertical leg of a triangle. This, again, is probably the biggest mistake that I see. Angle of elevation, angle of depression, always talk about someone's eye line, which is horizontal. So make sure that that angle is touching a horizontal part of a triangle. Okay? So now let's talk about the actual problem. So we have a waterfall, and then we have a boat, and it is 25 feet downstream. So this is 2,500 feet, 2,500 feet. The angle of elevation from the observer to the top of the falls, so the observer is on the boat, up to the top of the falls, is 4 degrees. Now again, angle of elevation means I have to start at a horizontal. Hopefully we can see our right angle in here. I'm going to draw it again in blue. So we have our right angle. Our angle of elevation has to be this angle. Again, it's the angle that starts on the horizontal. So that is 4 degrees. Right, we want to find how tall the falls are. So that's going to be our vertical leg. I'm going to call it H for height. Doesn't matter what you call it. And then we have 3 pieces of information, just like we did before in solving generic triangles. And again, all we're looking for this time is just one of those pieces. So we've got an angle. We have the side that is adjacent to the angle, and we're looking for the side that's opposite the angle. So we have adjacent and opposite. That comes from TOA, so we want tangent. So this is telling us that tangent of my angle is the opposite over the hypotenuse. That's a 5. So tangent of 4 degrees equals H, what we're looking for, over 2,500. So H, kind of running out of room here, is 2,500 times tangent of 4 degrees. Okay. And if we do that out, and again, you should be verifying this on your calculator, you should be getting 174.82 feet. And if you Google the height of Horseshoe Falls, I think it says it's 175 feet. Okay. Just again, make sure that your calculator is in degree mode, not radian mode. Okay. So hopefully you've done it out. Hopefully you get the same answer. So let's try another one. One level of an airport is 22.5 feet above the level below. An escalator 48 feet long carries passengers between levels. What is the angle at which the escalator moves from one level to the other? Okay, so the first thing we're going to do is draw it out. We have a level of an airport. We have an escalator, and it's moving up to the other level above it. So we know that the airport levels are 22.5 feet apart. So this is 22.5. The escalator is 48 feet long. Now I have a lot of people who will tell me that the horizontal part of my triangle is 48 feet. But my escalator is not a horizontal piece of equipment. My escalator is moving up and down. So this here, the hypotenuse, is the 48 feet. Okay, the escalator is the hypotenuse, not the horizontal part. And then again, hopefully we can see our right triangle here, which I've outlined in blue. And the question says, what is the angle at which the escalator moves from one level to the other? So there are two angles inside my triangle. Which angle is it that I want? Sometimes it can be a little difficult to tell, but in this case, they do want the angle of elevation, which is typically the angle that we want. We want something from a horizontal, not usually from a vertical. So this is the angle that we want, and I'll call it A for now. Okay, and again, we have three pieces of information. We have the hypotenuse, the vertical leg, the 90-degree angle, and we're looking for one of our other angles. So according to our angle A, we have the hypotenuse, and we have the side opposite it. And so that means we need sine. So sine of A is opposite over hypotenuse. Right, which means if I know sine of A and I want A, I have to hit it with sine inverse. So A is sine inverse of 22.5 over 48. And again, I just plug that into my calculator. Be careful with parentheses, right? You want to make sure you're doing sine inverse of 22.5 divided by 48, not sine inverse of 22.5 divided by 48, which will give you an error. Okay, so if you do this correctly, you should be getting 27.95 degrees. Again, make sure your calculator is in degree mode. Okay, so let's try another one. It says that we have a street light that's designed below, and we want to know how high above the street is the light. So we're looking for this height, which I'll call H again for height. I already know part of it. I know the 28 feet. So really what I'm looking for is the height of, again, hopefully we can see this triangle, this right triangle right here. So we're trying to find the height of this triangular part at the top, and then we can add that to the 28. So I'm going to call that A. So H is 28 plus A. Okay. So we know our angle, we know the hypotenuse, and the side that we want is the opposite side, which again tells us that if we have opposite and hypotenuse, we need sine, because we need SOHCAHTOA. So sine of 20 degrees is A, my unknown, over my hypotenuse, 12.5. Just swing the 12.5 over, and A will be, if you do it correctly in your calculator, 4.28 feet, which means that the answer to my question is 28 plus that, which is 32.28 feet. So again, once you have the picture, it's really nice. You're just solving for one piece of this triangle. Okay, but again, you have to make sure you have the picture. Sometimes it'll be given for you, as it is in this example, but most of the time it won't be. So let's try our last example. On level ground, a tree 12 meters high has a shadow 85 meters long. What is the angle of elevation of the sun? Okay, so I'm going to draw the picture out. We have a tree. It is casting a shadow. And I know a couple of things. I know the tree is 12 meters tall. I know the shadow is 85 meters long. What is the elevation of the sun? So remember, the sun casts the shadow. So the sun is up here somewhere above the tree or behind the tree. And again, it's the angle of elevation, which is the angle that's attached to the horizontal part of our triangle. So I'm looking for this angle here. Calling it theta. Typically we have angles as theta. Again, you can call it whatever you want. Okay, so hopefully, again, we see our right triangle here, and we're looking for that angle that is attached to the horizontal part of our triangle. Okay, so I have the opposite side and I have the adjacent side. So opposite and adjacent, I want TOA, I want tangent. So tangent of theta is opposite over adjacent, which again means that theta must be tan inverse of my 12 over 85. Right, and if I do that correctly, I'm getting 8.04 degrees. It's a very small angle, but if you look at it, the tree's 12 meters, its shadow is 85 meters. This is clearly not drawn to scale, so it should be a fairly low elevation. Either the sun has just risen or the sun is about to set. Okay, so read through the book, try out some more of the problems, and let me know if you have any questions. Thanks.